this one. Lesson 40 has us talking more about 0 as a placeholder and also pie graphs, circle graphs as the book calls them. We've been adding and subtracting, even multiplying with decimals, and for once with Dax, and we're going to continue to work on kind of a similar concept all in a row instead of jumping away and then jumping back into it later. And we've got it again here today, and if you recall, when we subtract with, decimals, like here, a half minus 32 hundredths, we end up with, well, first of all, some zeros to the left of a decimal. And it's good to remember any zeros to the left of whole numbers mean nothing, right? This is just 3, even though I have the 0 here. Same with any zeros to the left, to the right of decimal parts. I can put a bunch on here. It's still all just worth 3 7/10. So zeros to the left of wholes and to the right of decimals don't really matter. Don't get me wrong. The zeros in, for example, this 300 matter because they're to the right of a whole number or between an integer and its decimal. In that case, we call these placeholders. I've maybe used that term placeholder somewhat freely, thinking about 0 as just something that sits there and shows us the place. But a true placeholder is there and it has meaning, because if I didn't have these zeros, then the 3 would get demoted to here, and that's only worth 3. That's a 297 difference, right? To drop down, we need these to make sure that it's properly placed up here, moved over to the hundreds place. In the same way, when I multiply 2/10 times 3/10, I get 6, of course, but then 3 times 0 yields a 0 here. I have a decimal and then another 0. Now this 0 doesn't really affect anything. Like I said, it's to the left of the decimal, and it's not holding a place between the integer and the decimal. It's just a 0 hanging out there. This one doesn't really matter. This one doesn't. These don't really matter. But then we've got this interesting 0 here. And when I've got a decimal like this, if I say that the 0 didn't matter, then I would have to think of it as this. And are these the same? Absolutely not. 6/10 looks like this. 600ths is going to, on your calculator, if you divide this out, it's going to be worth a lot less. Smaller decimal number. So, subtracting these, you line up your decimals like we've learned. Maybe toss a 0 on here, not that it holds any value, but we've just talked about how it might be good to have it there to have everything in line, so this is all in box shape, if that makes sense. And we don't have like a gap like we do here. Whoop, that doesn't look very nice, and some people don't like to subtract that way. And then it reminds us that we're borrowing to make a 10, and then a 4 here. 10 minus 2 is 8. 4 minus 3 is 1. Don't forget to drop the decimal. And you don't have to show this 0 here. Can you check subtraction? Yes, of course you can. Follow the rules that we once learned that way. But I'd like to move on. Page 206. Subtracting 4/10 from 3. We place a decimal point on the back of the whole number. 3 dot. Line up our dots, our decimals. Fill in any empty spaces with 0. We subtract. Now when multiplying, we may need to insert 1 or more zeros between the multiplication answer and the decimal point to hold the other digits in the places that they belong. Let me show you. 0.2 times 0.3, we multiplied and we got this 0. So this is review. And if we didn't put that there, 6/10 would be much more than the 600ths we're supposed to have. What if we had to use digits to write a decimal number, and we have to write 12 thousandths? Well, we'd have to remember our place values, and thousandths go tenths, hundredths, thousandths, and I have 12 of them, so I put the rightmost number here, and I put the 1 in the hundredths place, but that's 12 thousandths. Uh-oh, what do I do here? Let me change my color. That's a true placeholder 0, isn't it? I need to put something here so that it's not like this, because this would be wrong. This is a placeholder 0. Hoping that makes some sense. All right. Circle graphs, sometimes called pie graphs or even pie charts, display data like the fractions we've learned with the pizza fractions, but in a circle. Nice visual way to see percentages especially. The next example uses one to talk about student pets. Brett collected information from his classmates about all their favorite pets and what they owned. 16 had dogs, 8 had cats, 4 birds, 4 fish. How many pets are represented in all, says letter A here. You add up all the numbers, 16 plus 8 plus 4 plus 4, that should give you how many total pets, right? So that's 32. Important for B and C, what fraction are birds? In this case, we're going to take then that total, because we've learned fractions are the part of a whole. So of a whole, then how many are, what is it asking for? Birds in all the pets. How many birds? Not 8, not 16. There's 4 right here. Am I done? Now you can divide these by a GCF of 4. 1/8 of the pets are birds. I'll mark off half if you don't reduce. Remember that. Now percent, remember we use this guy talking about per 100. How about dogs? Well, once again, we've got 32 as a total. How many dogs? 16. Maybe you can see right off the bat that 16 goes right into 32 twice. It's exactly half. Or you could have found GCF, which is going to be 8, and then maybe another, 16, but you could have maybe gone to 8 and had 2 over 4, and then you realize, just could have done 16 in the first place as our GCF. Then we can turn this into something over 100. And what times 2 is 100? 50. So 1 times 50, because we have to keep this all the same. 1 times 50 over 50 is 50 over 100. And then we say per 100, 50 per 100 cent. Or you could take your 1/2, divide by 2 like the fraction's really saying. You get a 0 here, 0.5, and then we remember with percents, you go 1, 2. That's another way we do these. Either way, whatever you find easiest, as long as you're getting them right, I am happy. I'm happy. Or you use your fraction manipulatives. That's the third way you could know that 1/2 is 50%. Here's another example you can read about on your own, using a graph, a bar graph, to create a pie graph. It helped us visualize quantities relative to each other, but the circle graph helps relationship to a whole and really shows percents like 66 and 2/3%, to 33 and 1/3%, the oppose, real nicely. So I would love for you to do B, D, F, H, and J. B, D, F, H, J, please. Thank you.